Hi, everyone. Well, first, thank you to Florida and everyone that put this on. This has been just enlightening. I love all of the research that has been presented so far. Um, my name is Nicole Hutchins. I am in Gautam Biswas's lab at Vanderbilt University. And my connection here is one of my mentors, or I consider a mentor, is Suchi Grover. So thank you, Suchi, for inviting me to this. I'm going to present on debugging for synergistic learning during STEM computational modeling. So our approach is really perhaps slightly different than what I've seen so far in that while we've done our analysis in our system, we've recognized the importance of debugging in helping students learn both their computational thinking and their science as they're building computational models. So I'm going to talk a little bit about how we found that and kind of the future directions that we're going. So the context is C2 STEM. This is our block-based programming environment. It's a version of Nets blocks, if you've seen that, or Snap. And what we've done is a few key changes or additions to Snap. We've created these domain-specific modeling languages. So you can see here, our blocks are specific to physics. We also have them in earth science, marine biology, genetics, and working on more. So the goal is really to have this self-documenting code in the language of the science that they're learning. We also have added this step-by-step programming approach. So when students are modeling, it's not necessarily it's not like a traditional science approach where they're memorizing equations. Here, they're looking at these step-by-step changes in position and velocity as Flash here moves to the right. And other tools that we've added are data tools so that they can have multiple forms of information about their model to help interpret what's happening. And with that, our whole curriculum, or we apply a design-based research approach where we utilize evidence-centered design. So we really unpack the science, the CT, and what students will be applying, the concepts and practices, so that we can map those to the assessments. We apply formative, summative assessments, and also preparation for future learning assessments, which I'll talk about in a little bit, but also map them to the actual tasks that they're building. So if they're going to be assessed on the relation between velocity, position, and time, we want to make sure that they have enough application in the model building process to hopefully learn that concept and do that or apply it well on a paper-based summative or formative assessment. And overall, we've really tried to dive into how students are framing their model construction and completing the model construction. So what strategies that they apply. And this includes their semantic understanding of the code. In past research, we've seen this issue with students translating science knowledge into code. So hopefully with the DSMLs that helps that process. How they utilize the visualization from the Snap environment, but also the data to either identify errors in the code and make correction, or just to check whether their assumption about their science understanding is correct. And also diving into their development process. So are they learning useful strategies to build models over time? So with that being said, we've done a lot of analysis, different types of approaches to looking at their student work. Strategy analysis with Dr. Biswas, we applied differential sequence mining. So that takes a look at high and low performing students, typically a median split of their summative assessments, to see differences in strategies that students might be applying. Also Markov chain analysis, which is looking at probabilities between actions to see kind of what are the most common sequences of actions. And we found that students that are the higher performing students are applying more systematic data-driven debugging strategies. So they are leveraging the data tools to identify the error in their code and make a correction. While the low performing students, following along with the debugging literature, even as I think it was Yasmin said from decades ago, they tend to apply this depth first approach that is common with novices. And then really a key thing that maybe an aha moment for debugging for us is discourse analysis. Sorry, that's my bad. We always record either collaborative model building or individual model building during a classroom setting so that we can see in real time how students are discussing their model construction. So think alouds, we have tried that as well, but in this case, we're seeing, how students, when there is an error, how are they working together? And in some of our recent work, we've seen that debugging offers this unique opportunity for this socially shared regulation to really understand the problem and develop the knowledge needed to fix that problem.
Sorry. Yep, finish your last sentence, sorry, go ahead.
Okay. Oh, is that already 5 minutes? Oh no. So just as an example for here, you're seeing that a student utilized the data tool. The problem was that they put y position is equal to 0 instead of less than or equal to 0. So from the logs and from the discourse, we're seeing this good practice of using the data tool. So since I'm finished, I just wanted to say thank you to Gautam Biswas, Suchi, and all of our C2 STEM team. If you're interested in our work, I'd be happy to share.
Thank you. All right, so let's open it up. And if y'all don't mind, we're probably going to run a few minutes past 4:30. So hopefully that's okay for folks. I wanted to make sure there were such wonderful questions. I didn't want to interrupt those. So I apologize for that a little bit. So let's open it up for questions for Nicole. Mia just said, would love to read the articles you cited in your presentation.
Yep, I can send.
We actually started a drive with articles, and that's one of the things afterwards I'd love for us to have a conversation today and kind of moving forward in terms of how to continue this conversation with sharing articles, sharing wisdom, sharing experience. So we'll send that Google folder to everybody and make sure everybody's part of that. Okay, so other questions for Nicole? All right, so let's move on to last but definitely not least, Chaima.